Hello and welcome back. Today we are learning one of the most important foundations in programming, how to ask the computer questions and how to make it answer with true or false. So let's jump right in. Let's start with the simplest version of a Boolean expression, a comparison between two numbers. To keep things extremely clean, we use only whole numbers in this video. Nothing else, because you can use all of this with other variant types as well, but we will get to this eventually. For now we stick to integers. So let's go through this list and clarify what each symbol means. The double equal sign means, is it equal? Is the number on the left equal to the number on the right? This means not equal. So is the number on the left not equal to the number on the right? This means less than. So is the number on the left less than the number on the right? Then we have greater than. Is the number on the left greater than the number on the right? Then this one. This means, is the number on the left less than or equal to the number on the right? This symbol means, is the number on the left greater than or equal to the number on the right? In this first case, is 10 equal to 10? Yes, it is. So it evaluates to true. The computer tells us, yes, this is true. Is the number 10 not equal to the number 10? No, that's not true. It is false because they are equal. So we get false as the answer of this question. Is the number 4 smaller than 10? Yes, it is. So we get true as our answer. Is the number 10 greater than 5? Yes, it is. So we get true as the answer. Is the number 10 less than or equal to 10? It is not less than, but it is equal to. So it will be true. And the last one, is the number 20 greater than or equal to 40? It is not greater than, it is less than 40, and it is also not equal to 40. So this evaluates, or the answer to this question is false. The moment you type one of these, you're not creating a number or something like that. You are creating a question, and the computer answers with a Boolean value, as we saw. This is already powerful. Just by comparing numbers, we can express rules, conditions, limits, thresholds, everything. So this is really important. This is the core of all of this. We ask questions and the computer answers it with either true or false. We can dissect this even a little bit further when we go down here and check out the actual answers when we print them. So for this one, the answer is true if we print that out. For this one, it is false. For the next one, it is true again, true, true, and false. If we print that out, it gets evaluated or answered first, and we only get one value of true or false. Instead of using fixed numbers, we can replace all our values with variables. And because we are hacky programmers, we don't like fixed numbers. We want them to be variables. I just wanted to show you that you can replace all of those fixed numbers with variables. You can use the keyword not to flip a value, to flip a Boolean value. So if you type not true, it becomes false. And if you type not false, it becomes true. You also can do it with the questions we have introduced, these Boolean expressions. You can type not in front of one of them, and the computer will flip the answer. In this case, A is 1 and B is 2. Is A less than B? Yes, it is. it would evaluate to true, but because we flip it, it evaluates to false in the end. Not means, give me the opposite of the answer. If something is true, not makes it false. If something is false, not makes it true. You can use the not keyword or you can use the exclamation mark. Both work the same. Now it gets interesting. You can connect multiple questions together using the words and or. These let you form more complex logic. The keyword and means both parts must be true. So the left question we ask and the right question have to be true, and only then this gets evaluated to true. For example, only open the door if the player has a key and enough strength. So only if those two conditions are fulfilled, then the door will be opened or something like this. Or on the other hand, means at least one part must be true. For example, show the secret ending if the player is level 50 or has completed the bonus quest. For the or keyword, it is only one of them has to be true. If both are true, only better. There is no limitation of how many ands or ors you can add in a combined question. We can use this little overview. For and, it behaves like the following. So if both values are true, it evaluates to true. If one value, no matter on which side, is false, it evaluates to false. If both values are false, it is false. So there's only one case. If only both are true, then it evaluates to true. For or, it is a little bit different. If both values are true, it evaluates to true. If one value is true, it evaluates to true. So doesn't matter on which side, if one value is true, it always evaluates to true. And only if both values are false, then it evaluates to false. So only one needs to be true. Now what happens if you mix these operations? So if you put and or and not in one big question, which one gets evaluated first and what is the order of execution here, basically? Just like math has its order of operations, multiplication and division before addition and subtraction, the order for those Boolean expressions is not before and, before or. This means Godot will always try to evaluate not first. So let's check this out. This block will be evaluated first because we have a not in front of it. Let's check this out. Therefore, we need to first evaluate the question, is A equal to B? No, it is not, because A is 1 and B is 2. So this will evaluate to false. The computer gives us the answer false. And because there is a not in front of it, this will flip this answer to be true. The next step would be to go and solve the AND. The computer will evaluate the AND next. So this is the AND expression right here. We already have the left side. It is already true. We need to evaluate the right side here. So is A less than B? Yes, A is less than B. So therefore we get the answer true. And now we have to solve this expression right here, this AND expression. So let's check this out. True and true is true, because both values are true. It will evaluate to true. And now the last step would be to evaluate the OR. So true or A equals 0. So before we can evaluate the OR, we need to get the answer to this question right here. So is A equal to 0? No, it is not. A is 1. So this is false. And now we can solve the OR. True or false will evaluate to true, as we know, because one of them has to be true in order to make this expression here true. As we did with math operations, we can use parentheses to change this default order of execution or order of evaluation. Let's check this out. The natural order of execution for this one would be to solve the AND part first and then the OR. If we put brackets around it to make it a little bit more clear, we can see that this will be evaluated first. So is B less than C? B is 2 and C is 3. So yes, it is. It evaluates to true. Next, is C less than A? No, it is not. C is 3, A is 1. So false. True and false evaluates to false because both values must be true in order to make an AND true. And now the OR expression is being solved. Therefore we need to, the right side is already evaluated. Therefore we need to evaluate the left side. Is A smaller than B? Yes it is. 1 is smaller than 2. So true. True or false evaluates to true because only one of them has to be true in order to evaluate this to true. And now we go and change this order. Remember, this evaluated to true. Now if we change the order by using the parentheses, it will evaluate as follows. This side, this OR expression will be solved first, and then the AND expression is being solved. So let's check this out. Let's start with, is A smaller than B? Yes, it is. Is B smaller than C? Yes, it is. True or true will be true. And now the left side is already evaluated. We need to evaluate the right side. Is C smaller than A? No, it is not. It is bigger, so false. True and false will evaluate to false. So in the first one, we had the expression evaluated to true, and only because we changed the order of evaluation by using parentheses, the output or the end of this evaluation is now false. And in real code, when expressions get longer than one line, most programmers always use parentheses, even when they technically don't need them, because clarity is more important than saving 2 characters. Boolean expressions are often built on top of math expressions. So basically you can combine math with Boolean expressions. First, Godot evaluates all the math right here, and then it will start to evaluate the Boolean expressions. Let's check this example step by step again to make it really clear and how to practice this and how to think about all of this. Let's start to evaluate the math first, without thinking about the Boolean logic for now. So let's start by replacing those variables with numbers. And now the next step would be to solve this math operation right here. So 2 times 100 is 200. Then we add 1 to it, and then we go to the next. In this case, we divide b by 2. Let's replace b by an actual value and a. So a is 1 and b is 2. So we divide 2 by 2, which is 1. Then we multiply 1 by 20, which is 20. And then we subtract 1 minus 20 and get minus 19. Let's do this one. We replace the variables and then we go 10 times 1 is 10 plus 2 is 12. And now we are going to remember that not is being evaluated first when it comes to Boolean logic, so we do this first. Therefore, we need to get the answer to this question. Is 201 less than minus 19? No, it is not. So it will be false. And the next step is we flip this answer to be true instead of false with the not keyword. So this will be true. And now let's solve the right side of this AND expression. Is b less than 12? We replace b with the actual value. Is 2 less than 12? Yes, it is. So it evaluates to true. True and true evaluates to true because for AND both values have to be true in order for this to evaluate to true. So just remember, math operations come first and Boolean expressions second. Of course, we can print this and you can see the output is indeed true. Because everything works together, you technically can do this. This works, it is legal code, but it's almost unreadable. Always keep your Boolean expressions clear, short, readable, and relatable. Long logic chains create bugs. No one understands this, or it takes at least a little bit of time to go through this. Short and clear logic creates clean gameplay, so don't do stuff like this. Your future you will thank you, and everyone else who reads your code. Before we finish, one tiny reminder. I used only ints here on purpose, but many of these comparison ideas and Boolean logic also work with floats, with strings, and with some Godot specific types like vector2. We'll get to all of that naturally once we need it in actual gameplay code. Well, that's it. It was a lot. Try to wrap your head around all of this. Exercising and repetition is key because you really need to understand and get a feeling for what is going on here. So if all of this doesn't make too much sense now, we are going to exercise it in the next video anyways. So see ya in the next one. Bye bye.